Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and this is some beautiful exam practice video for you. I believe it's going to be one of my favorites, especially for the last question. So when you have a look at this question, I want you to first try it yourself, then go on with the video. Don't just go and go, oh yes, now I see, oh, I know. No, try it yourself. Here's the question A, B, and C. Try it yourself, and then we go on. When we look at the first question, it says there the straight line with the equation 3x plus 2y minus 5 equal to 0 passes through the point m plus 3, comma, negative 2. Calculate the value of m. Remember. If you've got a question like this, I can just take the x value of the coordinates, substitute it in. Same with the y value, and the left must be equal to the right. In other words, I'm going to make x m plus 3, and I'm going to make y negative 2. And then that equation must hold because it says it lies on that line. I'm just going to go and solve for m now. Distributing out. Oh my goodness, all the numbers become 0, so I'm left with 3m equal to 0. So therefore, m must be 0. Ta-da! Now, if you go and look at this, and I just want you to think about what's happening here. I'm telling you m is 0, so the coordinate is 0 plus 3, negative 2. So in other words, it's actually 3, comma, negative 2. If I substitute it in, 3 plus 3 times 3 plus 2 times negative 2 minus 5, my answer is 0. Because that's 9 minus 4 minus another 5, and that gives me 0. So yes, that for that value of m, that set of coordinates actually lie on there. Simple and as easy as that. Now let's go over to the B question. Two straight lines are given with the following equations. Y minus 2x plus 3 equal to 0 and y equal to px minus 7. Now, I don't like line 1. I don't like it. Why don't I like it? Because y is not the subject. So before I do anything else, I'm going to make y the subject so that I can read off the m value as 2 and the c value as negative 3. Because I don't even know where I'm going with it, but I love to make y the subject. And that's maybe a secret I can teach you. If you ever get an equation that's not in standard form, in other words, y is not on its own, get y on its own. Now let's look at the rest of the question. In line 2, I'm going to get an m value of p and a c value of negative 7. Weird, okay? But B1 asks, determine a value for p if L1 is parallel to L2. In other words, the two gradients must be equal. So therefore, M1 must be M2, so 2 must be P. That's my answer for P. As simple as that. Ta-da! Magic! Let's look at now the second one. It says, alternatively, determine a value for P if L1 is now perpendicular to L2. But for perpendicularity, M1 times by M2 must be negative 1. So let's substitute my values for the gradients in. So in other words, 2 times by p must be -1. So in other words, p must be -1/2. So if p is -1/2, then the two lines will be perpendicular to one another. Oh my goodness, this is beautiful. Let's look at the last question. Question C is possibly my favorite of this whole series. Question C asks, or actually asks you to prove that the coordinates A, B, and C can never be collinear for any real values of K. What? How on earth? I already see some of you freaking out. You know, you're throwing your phones all over the place, hands in their hair, throwing tables over. Hopefully not. But how on earth am I supposed to do this? Let me give you a bit of advice. If ever they ask you to prove that something can never happen, let's assume it did happen. Let's make like it is collinear. So how do I do that? Well, what do I know? For collinearity, the gradient between A and B must be the same as the gradient between B and C, must be the same as the gradient of A and C. But I'm just going to use two of them. So let's calculate the gradient between A and B. And that answer is 1/3. If I look at now the gradient between B and C, I'm again just using what they give me. If I simplify that, I get k squared plus 3 over -4. But what do I know about collinearity? Well, with collinearity, those two gradients must be the same. So now, ladies and gents, I'm basically going to prove that this equation doesn't have real solutions, because if they have real solutions, then it will be collinear. Think about that. If it doesn't have real solutions, well, then it can't be collinear. So I'm going to try and solve for k now. So timesing by -3, or -4 I get k squared plus 3 equal to -4 over 3. If I get k squared alone, I get k squared to be -13 over 3. Now I highlighted two things there. I highlighted the square and the negative. Think about that. If I square any value, any real value, the answer must be positive. Think about that. 3 times 3 is 9. -3 times -3 is also 9. It's a positive. So no matter what real value I put in there, can it be negative? Well, no. K squared must be positive. So therefore, the three sets of coordinates cannot be collinear for any real value of k. Wow. Wow, wow, wow. This is a beautiful, beautiful sum, and a wonderful trick for you guys going into grade 11 and 12. If they ever ask you to prove something cannot happen, man, assume it can happen. And that's actually a life lesson. There's going to be a lot of people who's going to tell you, you can never do it. Well, then try and do it. And I promise you, a lot of times you're going to prove them wrong. You are actually going to do it just because someone said you can't. So this is Mr. VG signing off. Go and have an awesomely amazing Beautiful rest of your day. Go and be awesome. Keep well. Cheers.